Marcus. Thanks for having me. Wonderful to be in Krakow. So I used to be a motion designer, right? And then a couple of years ago, kind of pivoted towards programming more and more. And crucially now, this is crucial for this talk, I'm working on my own UI framework, which, you know, that's not necessarily a sign of mental health, right? But I'm going to talk about how this came to be, what I'm using this for, why you want to maybe build your own UI framework, why you maybe would not want to do that. And then I'm also going to talk about some core concepts at the heart of this framework. So it all started a bunch of years ago. I was still young. I was, in the prime of my youth. I hadn't yet experienced how cruel commenters on the App Store would be, and so foolishly, I decided to make a game. I hadn't really programmed all that much, but I thought, if this doesn't work, then I'll just flush it down the toilet, pretend it never happened. But the game actually at some point was released, so, good. I decided, because I didn't know how to code, to use a framework, right? A framework kind of strips away a lot of the crucial menial tasks that you have to do in order to display something on the screen, and helps you to, fulfill certain tasks. And so Cocos 2D, which was the framework I used for the game, was a 2D game framework. And that actually worked out pretty well, but being a motion designer, I thought, well, it's not quite going to cut it. I mean, you can make 2D games, but you can't really animate it the way I wanted to animate. You can't really make it feel alive the way I want it to feel. And you can't really integrate 3D graphics either. So I started hacking this thing. This is, by the way, what the game then ended up looking like. So, I tried to make it feel alive and stuff that bounces, and in the background you see some little birds, and all of these things not possible in Cocos 2D. So another video that you can see here is lots of transitions, some 3D stuff. There's like the scarf in the background. This is the same video, but slowed down for dramatic effect. And as you can see, there's a lot of layered animation, lots of stuff going on. And so this was all this hack of Cocos 2D. And it's actually, a hack is kind of underselling it, because at some point it really became this thing by its own, right? Kind of step by step, it morphed into something else. And then after the game was released and all the horrible, horrible, hateful comments came in, and I watched a lot of television. Then I went back to work and actually convinced some of my clients, hey, why don't we do a prototype? Because I can now also program. So this is from one of the prototypes. As you can see, lots of little whimsical interaction. And still used that hack of Cocos 2D to do all these things. And I showed it around to a couple of people. Some people were like, yeah, that's kind of cool what you have there. What is that? And I thought, yeah, what is that? Hadn't really thought about it in any way that's a thing, right? It just sat there. It's kind of, a bunch of stuff. I don't know what it is. What are you going to do with it? Are you going to sell it? No, I haven't thought about any of these things. But that kind of convinced me, hey, maybe this is something. Maybe, you can make this into something. And so I decided to raise it all to the ground, to delete basically everything, but take what I learned from this stuff and build it up again in C++. And then, really tailor it to what I want it to be. So this then became my UI framework, which is called Meek. And now, why would you do that? Why would you build your own UI framework? Why would you not just give up, and use a third-party solution like Open Frameworks or Cinder, or just use whatever Android ships with, or UIKit from Apple, which are kind of, equivalent in some ways, but they do a lot more in a lot of other ways. Well, you would do that because you can build completely new things. I had seen this image on Dribble where it was just some guy. It was really just an image, just a Photoshop mock-up. He kind of slid away a little little Facebook feed on the screen or a little view on the screen. And I thought, well, I can actually build that, right? I can actually make this curtain thing come alive. So that's what I did. Tweeted that out, got a lot of likes, got a lot of followers. Very good, very good. And then another thing that, where you can kind of go beyond the usual stuff is an app we just released. I'm working with this American company on this. And so this is if you are talented at dancing, which I'm not. This is not me. Don't be fooled. You can also upload videos to this app, or you can film yourself dancing. It will then kind of put music to it, rearrange it, and much cooler, it will apply effects to it. So here you can see it kind of retimed the video a little bit, and then there's a particle effect on there that takes into account the motion of the video, and this is a screen capture of the app. I'm just sliding through the effects here, actually. And so it applies these little effects onto the video. There's actually a bunch of more stuff happening, which, yes, this is always popular, the emojis. Yeah, so this is another example of how you can kind of, if you have your own solution, you can make it adapt to you. If you use third-party solutions, you're kind of confined, right, by the stuff that they offer. You're not gonna build a particle effect if it doesn't support particle effects. And so the tools that you have and the tools that you use also oftentimes define you, and you start thinking without necessarily realizing that you are confined to this box. But if you have something that you build yourself, you can extend this box, and you're not that limited in that sense. So you can build these new things, and it also adapts to your needs. So I built it around really a very special use case also. I had seen this little stop motion animation on Vimeo where kind of a little letter was just rolling up, so in 3D, and I thought, how do I make this come alive? So I built this little GUI where you can just put like a mesh around an image, and then you can animate this mesh like so. Now I have to speak a little more slowly so that it kind of fits with the video. Yes, you can do different animations. One like that, or like that, or one of those. So I had this need, and I had this animation in mind, and I just basically extended the framework until it does exactly that. And same with this example. This is also with the company I'm working with now, which is founded by the co-founders of Vine, and we wanted to do a new live streaming thing, right? There was Periscope on the market, Meerkat, but we wanted to put a little different spin on it. We didn't just want people to use the camera and broadcast themselves out, but we wanted them to be able to add video, to add text, to add GIFs and all of these kind of things. And this is extremely expensive to do on, this is all iOS, by the way. This is extremely expensive to do on the device and wasn't really necessary 2 years ago. Nowadays, it might actually be possible. I think Apple released a bunch of things with the newer versions of iOS, but back then it was not possible. And so the solution was to use this framework that I have lying around, Meek, and to rebuild a lot of the GUI that you would usually find in UIKit, but with the GUI in Meek, you can it's actually performant enough that you can capture this image, do all this compression stuff behind the scenes, put it out over the network, and broadcast yourself out. So this is what that ended up looking like. You have the camera here, you can apply a bunch of different effects. Probably when I recorded, I should have used, prettier images, but this is an image. And so you can arrange these things, you can add text, creatively say hello. And you can add vines and GIFs. Well, you can't add vines anymore because Vine is dead, but theoretically that would be a possibility. So you also learn a lot about everything, about stuff, when you build your own UI framework, because it is this crazy thing. You learn a lot about low-level graphics programming, because that's, in a lot of ways, what a UI framework is. It takes away a lot of the a lot of the menial, difficult tasks to talk to the graphics API. So Meek right now supports Metal, it supports OpenGL, and OpenGL ES, which is the mobile variant of OpenGL. And so you learn a lot about how that actually works, how they're different, these graphics APIs, what similar concepts they have, and you try to make this work. Then also, of course, you have the GPU and the CPU, and there's always this consideration, so how much work do I put on the GPU? Is it always better to put work on the GPU, or maybe in some cases it makes sense to leave it on the CPU? What does the CPU do better? All of these kind of things. You learn a lot about existing solutions because Meek shares a lot of similarities with other stuff. So for example, UIKit, the framework that ships with iOS, it does a lot of the same stuff that Meek also does, and you don't have access necessarily to the source code, but since you know how you implemented it, you can actually make a fairly educated guess how they implemented it. And then you can, adapt your use cases of the existing solutions in order to, get more performance or just fit it better to their architecture. You also learn a lot about platform differences. So Meek now lives on iOS, on the Mac, and on Windows. And you have to do all the behind-the-scenes work and for the framework to talk to Windows and to talk to the Mac. And you realize what's different about these architectures and what's nice, what's not so nice, and so on and so forth. And since it's this big project, you also learn a lot about organizing code, how to make certain modules agnostic of other modules, how to make it testable, how to structure it in a way that makes sense and that also makes it extendable in the future. So one of the instances where I learned a lot about platform differences is when I worked with Reuters on Reuters TV. So this is across a lot of platforms, basically a stitched together news show that's supposed to feel like a real newscast. And so we wanted to, parts of this lived in the web. And so we wanted to have high quality transitions, but we kind of rendered like in After Effects. But we also wanted them to be dynamic, and we wanted to be able to adapt them. And so there wasn't really an obvious use case how to do that, but, well, you guessed it, we used Meek for that. And so this is what it ended up looking like. This is just the preview thing. So this is a transition. I mean, it doesn't look all that spectacular, but kind of the point is also that it doesn't draw attention to itself. But there are also other transitions that are more elaborate, like this one, for example, where you have some depth of field, some blur shadows, and all of these kind of things. And these were all rendered on a Mac in the cloud and then pushed down to clients. Oops. But there are also a lot of reasons why you would not do any of these things, why you would just break down crying and grow roses or something. It's a lot of work, and it never ends. You think, well, if I put in this one more thing, then it should be good to go, and no more reason to worry about any of this. You would be wrong. It will never end. But also, other people have to live with your code, which is a burden in itself, because you are the only person who knows how to deal with all of this. And if you integrate this into a project, there is always a learning curve for others to pick it up. And I've tried, when I went through this presentation, to kind of sweet talk this point, but there's really no way around it. This is a reason why you would not build your own UI framework. And then again, it's a lot of work, and it will never, ever end. So if you think about it, UIKit, right? Apple's kind of, I hesitate to say equivalent because UIKit does a lot more and it does it very gracefully. But they have like 10, 20 people working on this for 10 years. I'm one person who frequently needs sleep. So, there's only so much you can do. And there will always be more advances in the technology. Now there's AR. Now, and there's Vulkan out there now as a new graphics API. So there's always work to do. It will never ever end. But how does it actually work, right? What is that fabled framework thing, actually? So it's really this layer that sits on top of the OS. And the reason why you would use a UI framework is that it's always the same layer, regardless of the underlying OS. So it looks the same from an API standpoint on the Mac, on iOS, and on Windows, but it does all these different things behind the scenes. And so the way that it works is you have some input from the user. This could be a keystroke, this could be the mouse moving, this could be a touch, any of these things. And this then triggers the framework to basically invalidate parts of its state. And then the operating system checks in with the framework periodically, like let's say 60 times a second, and asks, so has your state changed? And if your state has changed, can you please re-render all of this and display that in the hardware? And so how does that actually work, this state stuff? This state stuff and this re-rendering. So you have this input. This input then comes to Meek in form of into the renderer. The renderer is kind of a wrapper for the graphics API. So for OpenGL or Metal, you know, all of these things that do things a little differently. So it comes in there, and then it goes into the scene hierarchy, which is kind of the core of it. The scene hierarchy, you can think of it as each object on the screen is basically a node. It's a little more complicated than this, but you know, in order to make this fit into 25 minutes. So each object is basically represented as a node. This is typically a graphical object, some sort of geometry with a shader attached to it. And so the render asks the root node, kind of the parent of all of them, has your state changed? And if not, please check with your children. And so it goes through all its children, they have children, and it asks, has your state changed? If so, please reflect that, rebuild your geometry, and then re-render yourself. But how does that, in turn, actually look like? What does that look like? So let's take an example. There's an object called mkpoly. The mkpoly is really supposed to draw a polygon. So it has a couple of options how you would draw a polygon. Let's say it has options corners and radius. So we have these two options. Now we think about how do we now construct geometry from this? Well, we just put 5 points onto the coordinate system. So you have the center point at 150, which is the radius. And then from that center point, around it, you have these 4 corners. And so these are called vertices. So you have these 5 vertices, 0, 1, 2, 3, 4. And the center one at 150 is the vertex 0, obviously. But then you need to connect these points, right, in order to draw them. And so how do you connect points? Well, you need to define a plane that the graphics API then has to fill with graphic. How do you define a plane? Well, you need at least 3 points. 1 point is just a point. 2 points is just a line, but 3 points can make up a triangle. And so what you do is you index these vertices and tell them how the triangles are formed, because you know it could be each vertex with 2 other vertices, but you obviously want them to be defined in a certain order. So our first triangle will be 0, 1, 2. The second one will be 0, 2, 3, and so on and so forth, until you have the polygon that you wanted to draw. And this is actually what this looks like in code. So on the left side, you have the code. This is C++. We're creating a polygon, setting the radius to 150. 4 corners is actually the default. We set show wireframe to true, and we added to the root node to the scene hierarchy, so that it becomes part of the drawn graphics. And show wireframe is actually just a convenience function. So this geometry always has a shader attached to it. A shader is just a little program that defines how the graphics API actually treats all of these triangles that you're defining. So in this case, we're saying each triangle that you get, please outline the borders and outline in this and that color, and outline the points in this and that color. So it just attaches a shader to it. It's a convenience function to do that. If we take that away, it'll just take the default shader, and this is just a solid color. Now, Meek has a lot of nice little different tricks that it does. And one of those tricks is that you can add extensions. So you have a bunch of primitives, like for example this polygon, but then you also have extensions. These can, as the name suggests, extend the underlying geometry. And so here, for example, we have a border extension. We instantiate that, we set the thickness to 20, set the color to some shade of red, and then add that extension to the geometry. So that the extension doesn't really care to what geometry it's added, it will always do the same stuff, and in this case, add a border to it. So the border itself also has some options. You can set it to distinct, you can set it to round, and it will then always be reflected in that. But in 2D graphics, and graphics in general, there is always one thing that you have to worry about. It's aliasing. So as you can see here, you have these disgusting looking artifacts there, which you don't want. And if you've ever played a game, you know getting rid of these aliasing effects is very expensive. The way that you usually do this is you go through every pixel on the screen, look at the neighboring pixels and decide if there's some contrast threshold, and if so, you smooth it out. This is an extremely expensive process because you also do that multiple times. So how can we make this cheaper? Well, the nice thing is we're working in 2D, so there's one dimension we don't have to worry about. And also, we already know where the aliasing is going to happen. It's going to happen at the border, and we already know where the border is. And so we just add another extension to it, an anti-aliasing extension, and it'll smooth out that border. As you can see, it just blurs that here nicely. And the way that it does that is, it's actually just another border extension. It works exactly like this border here, but instead of it transitioning to red, it transitions to clear. And it's not 20 pixels thick, but just 1 pixel. And that basically comes for free, and is one of the little tricks that Meek does. And the nice thing is you can add that extension to the previous extension. And again, it doesn't really matter what extensions come before it. It will just cascade down that list and apply all these little steps to it and form the resulting geometry. So as you can see, this behind the scenes is all still just geometry. And you can still change the base shape, and it will again cascade down all these different extensions and apply these same simple rules that I explained earlier. And these just simple rules, just enough of them, give rise to this much more complicated thing. So here is that app I showed you previous with the debug mode turned on. And as you can see, all of this stuff is still geometry, and it's blinking a little wildly. But yeah, it's just really these simple steps that that make up then this whole app, and that allows, this is my developer face, that make up then this app and give rise to this kind of complexity. And those are the core concepts of Meek and the reasons why I'm looking so tired. Thank you.